Hello everyone. In the previous week, we talked about inheritance. And this is the example we use, class post. So this post class serves as a superclass or parent class or called base class. And we have message post to extend the post class. So message post is a subclass of post. And also here we have another one, picture post is a subclass of post. About this inheritance, we say once you say message post is a subclass of post, it inherits everything from its parent, from post class. About this inheritance rule is what's private in post class is still private. So inside the post class, you have the username, timestamp, number of likes, and a list of comments. Those ones are still private to post class. So in message post, although you inherit it, but you don't have direct access to it. And about the inheritance, we talk about this one, it's a public inheritance. There are three other ones called protected inheritance. So if you replace this public keyword with protected, that's protected inheritance, and private inheritance, as you might be able to guess. And public inheritance just means the member function, the data members, you inherit from your parents. What's private is still private for your parents, but what's public, you get them as a public method. So what it means is inside the post class, you have get author, get likes. Those are public method of post class, and those ones become public method of message post. So if somebody have an object of message post, that object knows how to do get text, how to do print, and it knows how to do all the public member functions, get author, get likes, get timestamp. So that's public inheritance. Public inheritance just means what's public in your parent's class remain public in your class. Protected inheritance, it will narrow down. The most open modifier is protected. That means if this one is protected inheritance, what's public in the parent class, for example, get author, that was public in post class, become protected in message post class. Remember, protected means it's not open to public. It's only open to your subclass or children class or derived classes. So it narrows it down, narrow the public accessor to protected. And as you might be able to guess, for private inheritance, that means everything in your parent class becomes private. So if they have public or protected member functions or data, they become private. So you might be wondering, like how useful could private inheritance be? Because whatever you inherit, nobody else can see it. They all become private ones. So it could be useful if you say, I want to inherit those things, those implementation, but I want to provide an entirely different interface. So whatever you inherit won't be seen from the outside world. You can provide a whole new set of interface for your clients to use. But when you do those ones, you can use the inherited features to implement those ones. So almost like all the inheritance we use, you see are public inheritance. So that's about inheritance. In this week's lecture, we're going to look at the third principle of OOP, that's dynamic binding. And we also look at subtyping first. So now let's first take a look at subtyping. Subtyping, so let's take a look. I declare two pointers, and they're pointer to post. You see, it's not pointer to message post or pointer to picture post. It's pointer to post. So it's a pointer to the base class or pointer to the superclass. And now let's take a look. I create a new message post and assign that one to a pointer to post. So now you see the type information for message is post star. It's a pointer to post, but it can point to a message post object. How could this happen? You can think of this one. It's a is a relationship. So when you create a new message post is a post. Remember the is a relationship, kind of a SUV is a car, a message post is a post. So when you create an object of message post, you can assign it to a pointer to post. And pay attention here, it has to be pointer. In order for subtyping and dynamic binding to work, it has to be pointer or reference variable. Here we use pointer. So it couldn't be message post assigned to post object. It has to be pointer. A pointer to message post assigned to a message to a pointer to post. So pretty much subtyping referred to you can assign a pointer to the subclass to a pointer to the base class because of the is a relationship. And similarly, you can create a new picture post object and assign, so this new operator give you back the address, which is a pointer to picture post. You can assign it to post star here. It's all about the subtyping. So those two, that's called the subtyping. You can assign a pointer to subclass object to a pointer to base class or superclass object. That's called the subtyping. The other way, it doesn't work the other way around. You couldn't say I have a message post star and assign a post star to message post star, because there's no is a relationship there, because a post doesn't have to be a message post. It could be a picture post. So that's a is a relationship. That's subtyping. Now let's see why subtyping is important. Let's take a look at our newsfeed class. Newsfeed class, for this version, I changed it. For the previous version, we have two lists. One list is a list of message post star, and another list is a list of picture post star. That one isn't very easy to maintain. If I have an event post, I have to modify that code, add another list. Maybe later on, I will have another list. So now the modification comes this way. You have one big list. It's a list of pointer to post. So I can put message post pointer there because of the is a relationship, or I can put picture post there, or I can put event post there, because I use the pointer to base class here. Then we can use subtyping. So we can throw in all the posts inside this one big list and make it much easier to maintain. And now take a look at the add post. When we add a post, we didn't say give me a message post or give me a picture post. Instead, we say give me a pointer to a post class. So you can give me a pointer to message post, or you can give me a pointer to picture post. Because of the is a relationship, because of subtyping, this one will compile just fine. Now let's take a look at the implementation of newsfeed. Let's take a look at the print function. How about that one? So because the add post is pretty simple, so you just add the post. And the print function, let's take a look. The print function, the logic is very simple. We now have one big happy family, so you just loop through that big list. So you use the iterator, start with the beginning of the list and end here. Then you invoke the print function. Now let's see. At this point, you don't have to know, is this a message post or is this a picture post? Because both of them have a print function. Now we're wondering which print function should get invoked. Because message posts and picture posts, they have different print function. Remember last time we did the overriding We did the overriding here. Remember here, in post class we have a print function, and in message post and picture post we also have an identical prototype print function. You see, picture post we have an identical print function. It's called a function overriding. Function overriding just means you keep the prototype the same between subclass and superclass for that function. You inherit it, but you override it. So that's overriding. Now back to our newsfeed implementation. The print function here. We loop through all the posts and invoke the print function. Ideally, the print function for message post will get invoked if it's a message post. The print function for picture post will get invoked if it's a picture post. That will be ideal, and that's the idea of dynamic binding. Dynamic binding meaning, okay, here, so when you dereference 8, it gave you back post star. It's a pointer to post. It's a pointer to post, so that's a static type for that object. It's a pointer to post. It's a post star. But the dynamic type meaning which object am I really referring to? Because a star to post, a pointer to post could be a pointer to message post. It could be a pointer to picture post. Dynamic binding meaning the same print function will be bound dynamically. So it will say if at runtime, remember when you create a new object, it's runtime. If at runtime, this pointer is pointing to a message post, I'm going to invoke the message post print function. If it's pointing to a picture post, I'm going to invoke the print function defined in picture post. Okay, so that's the idea of dynamic binding. It's a very powerful idea. That means which function gets invoked depends on the runtime type information, not the compile time. Because the compile time type information for those are post star. It's a pointer to post. But we need to know the runtime type information, the subtype. Okay. Now let's take a look if this one works. Current post. So unfortunately, we see it doesn't work. It only gave you the implementation in the post class, the print function in post class. In the super class, it shows who posted how long ago and the number of comments. Please ignore the size for now. We will take a look at the size later. Remember, for message post, it should show the message, and for picture post, it should show the location of that picture. Unfortunately, dynamic binding isn't happening now. So what happened is still static binding. So ideally, it should be dynamic binding. The static binding meaning it look up the post class print function. It did that one. It didn't do the message post or picture post. So that's kind of sad. And now another bad news, we also have memory leaks. We didn't have memory leak before, but now we also have memory leaks. So how to fix these two problems? Let's take a look. So there's something important here. In order to make dynamic binding work, you have to do a virtual. So number one thing I want you guys to do is to make the destructor virtual. The reason we have memory leaks is, if you take a look, those memory leaks are about the message, about the file path. So the indication will be the destructor for the subclass didn't get invoked. So when we delete, remember when you go ahead in the newsroom, when you delete those posts, only the destructor for post class get invoked. The destructor for the message post or picture post, they didn't get invoked. So to fix this problem, we need to add virtual to the parents class destructor. After you add virtue to the parents class destruct, let's take a look. The print function still doesn't work, but now we get rid of the memory leak. So you have to put virtue in the base class to enable your subclass destructor get invoked when you use subtyping. So I will encourage you to put virtue in every single class destructor, because you don't know if it's going to become apparent someday. So you're doing your children class a favor, or your future children class a favor, to make sure their destructor get invoked when they use subtyping. I'm going to do that for all the classes, even for message post. Even for message post, it's a subclass, but it could become a parent class if somebody want to decide to extend message post to make message post a superclass. So if this one have a destructor there, you should make that destructor virtue as well. But this one doesn't have one, since we don't have pointer here. That's fine. So the default destructor works just fine. The default destructor for message post is just delete this text, and the destructor for string get invoked. So that's about the destructor and what you should do. You should put virtue in the superclass or parent class or base class. Put virtue there. The virtue there is to enable the subclass destructor get invoked, to make sure the destructor invocation sequence is correct. Remember, the constructor invocation sequence is you go up, initialize your parents first before initialize yourself. The destructor invocation sequence is the opposite. You delete yourself first before you delete your superclass dynamic member. So that's a destructor, the virtual destructor. We still haven't fixed the problem about the print function. And as you might be able to guess, this is what we need to do. Virtual keyword, that will enable dynamic binding. So if you don't have virtue, dynamic binding isn't enabled. Now the only change I added is to add virtue to the print function in superclass. Now let's take a look. You see this time, this is a message post, it got the message. This is a picture post, it got the picture file path and the picture caption. And we don't have memory leaks. Alright, so now let's see about dynamic binding and subtyping. Let's take a break and take a look. So subtyping refers to you can assign a pointer or a reference to the subclass to a pointer or a reference to the superclass. You can do that because of the is-a relationship. After you do that, when you invoke for example, if I invoke a message big arrow print, if I invoke the print function, that will be message post print function get invoked. If I invoke a print function on photo, it will be picture post print function get invoked because of dynamic binding. In order to enable dynamic binding, number one thing, you have to declare them as either as a pointer or as a reference variable. Number two thing, we just take a look, you have to add the virtue to the function, the overrided function, have to have virtue there in the base class. And also to make sure the subclass destructor get invoked, you need a virtue there for the destructor in the base class as well. So the virtue should be put in the superclass overrided function and the destructor. So that's about subtyping and the dynamic binding. Now let's take a look at this size function. Number one thing, this is virtual. That means you want to enable dynamic binding. That means the subclasses, they're going to override this one. The reason you put virtual there is to make sure it's a subclass version, the size get invoked instead of this one. But this function is different from print function in another way. You see, I have an equal to 0 there. And after I do an equal to 0, I turn this function into an abstract function, an abstract member function. An abstract member function meaning in the post class, I don't have implementation for it. So if you go to post.cpp, you couldn't find implementation for this one. Normally, after you declare something, you have to implement them. If you don't implement them, the compiler won't let you go. But in this case, the compiler let me go. It's all because I said this, equal to 0. That's my way to say, I don't have implementation now. They will come in the subclasses. So this is called an abstract function. Abstract function in C++, you just say equal to 0. Then you don't have to implement it. Okay, this abstract function, once you have an abstract function in a class, your class becomes an abstract class, which means nobody can instantiate you. Now think about this, makes sense. If somebody creates an object of post, but it has an abstract function, it doesn't know how to do size. So that means when they invoke size, there's no implementation for it. So abstract class, now think about the reason we create a class is we want objects out of that class. That's how a class could be useful, because we need object out of that class. Now for post class, you can never do a new, create a new post anymore, because it's abstract. Then why it's useful? So the abstract class is only useful as a parent for a structural reason. You don't create object out of post now because it becomes abstract, because it has an abstract function. Even if you only have one abstract function, this class becomes abstract. So nobody can ever create an object out of it. The post class only purpose, the only purpose it exists is to serve as a parent. It's going to just serve as a parent. And another thing about abstract function is once you make this one abstract, it's mandatory. So for all your subclasses, they have to implement, they have to override this one and have to provide implementation for int size. If they don't, they become abstract class as well. Then nobody can instantiate them. So the reason we have abstract function is you want all your subclasses to have the same behavior. This is how you insist. They all the same behavior but different implementation. So this is, as a parent, this is your way to say, all my parents, they have to know about their size. So that's how you do it. You make it virtual and you make it abstract. You make it virtual because you want to enable dynamic binding. You make it abstract because your children class, they have to implement it. You see, print function isn't an abstract class. So if some subclass, they choose not to override it, they're fine, because they inherit this one anyway. But for size class, all the children class, they have to implement them. If they don't implement the size, those subclass becomes abstract class. Let's see. Okay, the reason we have this int size as abstract, number one thing, we want all the children to override it. And number two thing, also you don't have enough information to implement size at the superclass. For post, you don't even know what kind of post is that, so you don't know the size. So for message post, that could be the length, the character array length. For picture, it could be the number of bytes there. But for post at the superclass, you don't have that information to implement this one. And also for structural reason, you want to demand all your children to implement this one. Now let's take a look at the picture post. Picture post, you see it has to declare this one, have to override it. And let's see, picture post. The size, it just do file size there. And message post, you also have to override the size. And message post, let's see the size function. It just go ahead and invoke the size function of the string class. Alright, so that's about abstract function and the abstract class. Abstract class is a powerful idea. When you have an abstract class, that means you have an abstract function. When you have an abstract function, that means all your subclasses, they're required to override that function. So you can be sure, like all your children, they have this size function there. And now let's take a look at the print function in post class. So you see in post class, it can just go ahead and invoke size. And as you might be able to figure out, this size isn't the size inside this post class, because that one is isn't even implemented. It's dynamic bounding. So depends on what kind of post is this, the different size member function will get invoked. If it's a message post, the size function in message post class will get invoked. If it's a picture post, it will be the other one. Alright, let's see. So that's about dynamic bounding, abstract class, abstract function. There's another thing I want to show you before we end this lecture. Let's see, in news feed. Remember in news feed, we have one big list. So when we do the printing, we just go ahead and invoke the print function. So here's a question. What if you really want to know, is this a message post or a picture post? For example, you want to print out all the message posts. How can you do that? So this is a code I commented out just to be less distracting there. Let's see. If I want to only display the message post, so you have to loop through. And this is what you need to do. You need to do a type ID checking. It's a runtime type checking. Type ID. So take a look at the type ID. Is that a message post? So you dereference 8. You get to the individual element of the list, which is a pointer to post. A pointer to post. Then you dereference that pointer, you get to post. So you see if this is a post, what kind of post is that? Is that a message post or a picture post? So just do it step by step. Dereference 8, you got to pointer to post. Dereference pointer to post, you got to the specific post. Alright, so that's how you do something we call it type ID, and you can do, if you really want to use it as a message post, for example, you want to invoke the message post specific function, you want to use it as a message post. Let's see what's specific about this one. For example, get text. If you really want to invoke get text, you need to do the typecasting. You need to do the dynamic cast and cast that one, cast this one to message post before you invoke that one. When you invoke print, you don't need to do the casting because the dynamic bounding is turned on. So about superclass and subclass, about subtyping here. Let's see. How about I'll show you here. If you say message dot, sorry, not dot, it's a pointer. You see, if I want to say get text, there's no get text there because the compile type of message is a pointer to post. So you have to do a dynamic cast. You have to do a dynamic cast to cast it into a pointer to. So how about if you do a message post, after you cast it, you can say message post. Now you can say get text. You see, those ones are inherited. This is your specific ones. So that's how you do dynamic typecasting. The idea is you can assign a pointer to message post to post, but once you want to use it as a message post, you have to do the casting. You have to do the casting to use it as message post. And if you invoke the print function, it doesn't matter because the dynamic binding is going on, and this post has a print function. About get text is a function defined in message post. That's why you cannot invoke it directly through message post there. Thank you.